Hey everyone, I just want to talk very briefly about the different data types that we're going to be using in this class. Remember I said that we're going to do analysis on a variety of types of data. I want to talk about the major distinction that we're concerned with, which is the data numbers or is it categories, right? So the two types of data we're going to be dealing with are quantitative data and qualitative data. And of course, quantitative data refers to quantities. And so this is things that are numbers. So for instance, in 1C from the previous video, Maria here was researching ways to improve patient care and health outcomes. So she's interested in optimizing the emergency department intake process. So she's gathering data on the time it takes between when a patient arrives to when they actually receive care. And the amount of time that it takes for that to happen is a number, right? 2 hours, 30 minutes, something like that, right? So that is numerical data, that is quantitative data. An example of qualitative data is anything that's a category. So for instance, again, previous question here, Lauren, the biologist, she is interested in some things about giraffes, their height, age, and gender. So height and age are both numbers. Gender is not. Gender is a category, right? And so qualitative data is anything that's a category or label, basically. So the answer to the question, what is the gender of this giraffe, is not a number. It is a label, male or female, right? Whereas the answer to how tall is this giraffe is a number. It's 17 feet 5 inches or whatever, however tall that giraffe is. And so that's the way you want to determine the answer, or determine what type of data you've got. Is the answer to the question that I am asking a number, or is it not a number? And the reason we care about this is that we do different kinds of analysis depending on what kind of data we've got. There are more distinctions in here, by the way, but for between quantitative and qualitative, we'll see one of them below in question 3 in just a second. But there's a few others, and I don't really care about any of those, because the only difference in the way we'll analyze data is whether it's quantitative or qualitative, essentially. And so that's what I want you to be able to identify. So, you can have more categories than just 2, right? It doesn't have to be male or female, yes or no, although those are very common. You can have several different categories. So for instance, what color are your eyes? That would be an answer with, blue, green, black, brown, whatever, right? There's a wide variety of colors that you could have. And so you can have several different categories as well for qualitative or categorical data. All right, so I'm going to pause for a second in here, and then we're going to do number 3. So pausing. Okay, number 3. So I want to identify each of these as qualitative or quantitative. So I'm just going to kind of go through them fairly quickly. Number of people in this room right now, pretty clearly a number. That's quantitative. The color of a car, clearly not a number, so it's qualitative. How much someone's rent is per month, definitely a number, that's quantitative. Whether it's raining outside, that's yes or no, so it's qualitative. The species of a tree, definitely not a number, that's qualitative. How long it takes to finish a test, that's a number, it's a length of time, so it's quantitative. All right, the last 3 are the more interesting ones. A student's pipeline username, that one's pretty clearly a label. You could make an argument that like the computer stores it as a number, but I think it's fairly clear that this is a label. That's qualitative. The most interesting one is H, the grades in my statistics classes. So A, B, C, D, F. Those letters are labels for numbers, right? 85% would be a B. But these are labels, right? So this is qualitative data, but it's qualitative data that has some of the properties of numerical data, of quantitative data. The specific property I'm thinking of is that you can put them in order, right? A is better than B, is better than C, etc. And so this is a type of data that is technically qualitative, since these are labels, but since it has some of the properties of quantitative data, there is some other analysis you can do on it. This data is actually called ordinal. You don't have to remember that one. For our purposes, it would be qualitative. We would analyze this like qualitative data. We just want to know how many things are in each category, right? Or what proportion of things are in each category. So for our purposes, this is qualitative data, but do know that it's not like cut and dried between, quantitative here and qualitative there, no room in the middle. There's actually a bunch of gray areas in the middle, which is kind of interesting. But for our purposes, we mostly don't care about those gray areas. Just qualitative versus quantitative. For us, this is qualitative. Student's cell phone number, that is a number, but it is not a number you can do math with. That number is really just a label, right? That person's name, like stored in your phone, is probably labeled as like their name, right? And then we associate a number to that, but the number itself is just a label to identify the person. So this, although it is sort of a number, it's not really a number that you can do any numerical things with, right? You can't really you can't sort phone numbers by number, right? That wouldn't work out very well. You want to sort them by name. So this is really qualitative data because it's just a label. Now, the reason I wanted to make that distinction between quantitative and qualitative data is that we will be interested in different statistics depending on whether the data is quantitative or qualitative. In fact, most of the time, qualitative data won't have the quantitative statistics that we need, and quantitative data won't have the qualitative statistics that we need. So the statistics we're going to be interested in are the mean or proportion. Those are the most common ones. There's plenty of other ones too, but we're going to start with the big ones that we use a lot, mean and proportion. So mean is just another word for average. It's the thing that we do with quantitative data. You can't average qualitative data, right? If I have 17 female giraffes and 18 male giraffes, I don't have like 35/2 half male, half female giraffes. That doesn't make any sense, right? Trying to find the average of a bunch of 17 females and 18 males makes literally no sense at all. And that's because you can only average numbers. So things that are qualitative, that are just different categories but not numbers, you can't average those. And so we use the mean only on quantitative data. Similarly, proportion, for our purposes, basically means what fraction falls into this category, or what percentage falls into a category. Well, we need a bunch of different categories then, right? Because we have to say what proportion is in each category, we need the categories. And so that's qualitative data. That's what qualitative data is. It's the list of categories. So in general, we use quantitative data. We use the mean most of the time on quantitative data, and proportions all the time on qualitative data. So that's why we want to make that distinction, is those two things are very different statistics and we'll need them for different purposes. All right. Let's quickly do number 4 again. I will pause here, pausing. All right. I want to do number 4. So using the data from problem 1 above, so this problem up here with that A, B, and C, I want to answer these questions. What proportion of the observed giraffes are adult females? What proportion are adult males, et cetera, et cetera, et cetera. So remember that proportion, scroll back down to it, proportion basically means fraction or percentage falling into the relevant category. So I'll just do adult females here, and then the others are similar. So if I want to know the proportion that are adult females, I need to find out how many adult females we had. We had 13 adult females out of the 56 giraffes. So if I was going to write that, I would write it something like this. And bear with me here, I have to write on my screen. So I would say that like P sub adult female equals 13 out of 56, right? And that would be it, right? We could certainly find a percentage for this. I don't know what the decimal is off the top of my head. You could turn that into a percentage or a fraction. I don't particularly care which one. I do want to point something out, that I'm using P for proportion, and then this right here is called a subscript. And it might be better to write it more like this: P sub data equals 13 out of 56. Right? Maybe that's a better way to say that. So proportion of that are adult females. So in other words, the proportion falling into this category is 13 out of 56. And you can do the same for the other ones, right? 12, 17. Well, I don't remember what all I said for the other one numbers, but there you go. All right, go back to the worksheet here. What proportion of the students fall into each grade category? So same exact thing, right? I've got 4 grade categories, or 5 if you want to count no response, A, B, C, and then D or F. Now, you might argue that Porter should have specified, 1 for A's, 1 for B's, 1 for C's, 1 for D's, and 1 for F's. When I was doing this, I was thinking he was doing like A, B, C, and then not category of not passing. But you got 10 out of 36 in A, 7 out of 36 in B, etc. Now, what you might want to do here actually is, if you're just trying to describe the grades, it might be reasonable to say the proportion in the A's is 10 out of 26, and you just disregard the decline to answers, right? So you're sort of treating decline to answer as not a category, right? And then you're thinking that your sample is only 26 people, which is actually a totally reasonable way to do it. So you'd say like 10 out of 26 of the responses had A's, and 7 out of 26 of the responses had B's. You could find the percentage of those as well. And then the last one, what is the mean time to treatment for Maria's emergency department? Well, we don't actually know what that is, right? So mean time to treatment for the whole department is a parameter, and all we have is a statistic, right? We have the statistic that of the 381 cases that she reviews, the average time is 2.1 hours from presentation to treatment. So in her sample, the 2.1 hours is the average time to treatment. For the whole department, we don't actually know. We would have to have population data for that, and we don't. What we have is a sample. So it's probably around 2.1 hours, but we don't actually know what that number is. That's the point I wanted to make here with 4C. So the mean time to treatment for the whole department, we're not sure of. Mean time to treatment in her sample was 2.1 hours. All right, that's what I wanted to say about those terms. So I'm going to go ahead and stop the recording.